All right, so today we're going to end up combining both those last circuits that we made with the ultrasonic sensor and with the screen. And we're going to combine those two so that we can end up using our screen. And instead of printing on this computer screen the data from this, we're going to actually print it on our LCD. So to start with, I'm going to start by doing our normal powering of the rails. We're going to need power for both of these items, and we only have one power outlet for our Arduino from our Arduino. And so we're going to end up taking positive 5 volts from the board and negative and a ground from the board. So I just have that. I'm sticking that in positive and negative. I'm using red for our positive, blue for our negative. I'm going to power this side of the board here. I'm going to stick both of those in there just like that. Ground to ground, positive to positive. And then I'm going to end up, so this rail is now charged with positive 5 volts and a ground. I'm going to end up taking our sensor. I'm going to stick it down here at some point. I'm going to stick it all the way down at the end. Make it easy on myself. And I'm going to first go and just power the outside two rails, because we have on this outside rail here, we have positive, and on this inside rail here, we have negative. So I'm going to keep the same color coding kind of going here. I'm going to grab a positive there. I'm going to put that in a positive rail here. And then I'm going to grab a blue, grab the outside one here, and put that in the negative. Just like that. So we have those two outside rails because we have positive VCC and ground, and I'm just hooking that to the powered rail from the board. Just like that. Keeping the color coded going so we can kind of keep things straight. The next thing I'm going to do is, on our last circuit, we had trigger hooked up to D9 over here, and we had echo hooked up to D8 over here. So I'm going to go ahead and do that. I'm going to grab two signal wires so I can hook that up with. And D8, stick that on our board, and D8 was plugged into echo. This is the one next to the negative. And D9 was trigger, and that's hooked to the right next to the positive there. So we have those four leads. We have our sensor hooked up. Oh, bumping the camera there. But we have D8 and D9 hooked to the corresponding trigger and echo. Remember, D9 is trigger and D8 is echo. All right. See if we can get focus better. So now we have the sensor hooked up, the ultrasonic sensor. That circuit's done. We're going to add in the screen circuit. And remember, whoa, can't talk apparently. Remember that has ground, VCC, and our two signal wires. These two signal wires go into our A4 and A5 on this side of the board. So we can end up with this. You can strip these two wire sets, or you can keep them together. And that's totally up to you. In this case, I'm going to strip these just like that. And so now I have a brown and a red two set. I'm going to stick that in my power set on this I²C backpack. Let's see if I can get this right. Ground and positive. All right, so we have ground and positive. Oh, it's pulling it right off. All right, we have ground and positive, and I need to power that with 5 volts positive. So I'm going to end up still keeping kind of the color coding going here. Red is our positive. Some darker neutral color is our negative. I'm going to stick that right in our breadboard for power. All right, so we have power now to our board. And I'm going to take our other set, signal wires, and we can plug that directly into our signal wire board, or our board like we had before. So we can have that as SDA is orange, and SCL is yellow, and SCL goes to A5, and SDA goes to A4. So in this case, I'm going to have SDA, which is orange, go to A4, and SCL, which is yellow, go to A5. So orange to A4, and yellow to A5. So we just have orange to A4 on our board, and yellow to A5. So there we go. Now we've got our circuit completed. Very simple. We're just using the power rails to power everything, and we have the same two setups like we did before, just combined. So let's hop over and let's do some coding for this. All right, so I'm going to start here with a new sketch. This is an old sketch I was working on. Go ahead and start with a new sketch here. I'm going to save file, save as right away. I'm going to save this as the SR04. Dash 16 by 2 LCD. Save that. And to start with, I'm going to put some enters in there. I'm going to start with my cursor up here, put the enter in there so I can get some space up front, so I can run some comments, put my variables which I might need, and bring in my libraries before my setup. And I got a little note over here that I'm going to just copy paste in just because it's easier. And this is just telling us with that comment out section like that we have our sensor plus our LCD screen plugged in with the address that we already know for this screen. And then I have my wiring, basic wiring, which is that LCD wiring that we talked about just previously. And then we have that sensor wiring that we just did previously. Kind of talking about what this program will actually do. And we'll go from there. So to start with, we're just combining these two things that we just did previously, which is the LCD screen and the ultrasonic sensor. So we literally just have to combine those two, and instead of printing to serial, we're going to be printing to the LCD screen. And so it's just combining those two codes together to get this to print out. And just like before, we had to use wire.h and we had to use liquid crystal underscore I²C.h, which is the I²C toolbox for the wire, and then the easy commands for the I²C LCD. So to start with, we've got to include that. So we have to include, and in this we want to do wire, the uppercase wire dot h, and then we want to, and also another include, and that's a liquid, LIQUID crystal. Can't spell it, CRYSTAL underscore I²C. Make sure it's all uppercase there. The H. Remember, this is an uppercase sensitive language. We have to have that spelled correctly, and we have to have those items uppercased that need to be uppercased, right? And again, that's just an I²C toolbox, and that's for us in our analog setup for those two SDA and SCL pins, so we can initialize those to be I²C setup. And then this is just the easy commands for our I²C screen, LCD screen. And like we did again, we have to actually pull up liquid crystal I²C, and then we have to name this something. In this case, again, I'm going to name it lowercase LCD, and then we have to give it its address and its size. And so that's the address of 027. And what was the 16 2. And then we have to close that with the semicolon. And again, so we're just naming that LCD. We're giving it an address, and we're also saying, hey, you have 16 columns and you have 2 rows for that LCD establishment. So now that we established that, I also want to put this little comment in here because there's other addresses. Our screen isn't that address, but you can have an address that looks like that for your address that would go here. Different screens might require this address. It just depends. I just want to point that out. So the next thing we have to do is we have the establishment of our 2 pins. And normally we could do the pin mode, the number, and the output and input like we did down here with that. But I also want to just label these things like we've talked about before. And so that's like establishing an integer, right? And we have the 2 pins, which are pin 8 and pin 9, which is a trigger and echo. And we can do a trig pin equals, what was that, 9? Making sure, yep, trig pin 9. And then we have an int, and we have an echo pin equaling 8, and we want to close that. And so that's just naming those so we can pull up the name easily, and we don't have to remember what pin it's plugged into or anything like that. So that's essentially our pre-setup before we go into our setup loop. We have those libraries pulled up like we did before. We named our LCD like we did before. And the only thing difference here is just like in the ultrasonic programming, we have our echo pin and trigger pin. And so here we can jump down into the setup. And in the setup, we're just going to essentially combine, hey, we have the pin modes for the 2 pins. And then we also have, hey, initialize LCD, turn on the backlight of the LCD. And then I'm also going to do a little bit of print here because I want some static printing going on, at least for our first row, right? And so what we can do here is we can establish pin mode for both of those pins, 8 and 9. And remember that's what the pin is, the number of the pin, or the name of the pin in which we gave it. So we could have put a pin 9 here, but we put trig pin. And then we have to establish whether the trig pin is an input or an output. And the trigger pin is an output because we're sending data out. So that thing it's those microsecond pulses, those 8 microsecond, the burst that we're sending out, and the other one's picking up. So the other one, the echo, is a pickup, is an input. And then we have another pin mode. There we go. The echo, which is that pickup. And that's an input like we have from the other one. You could end up, instead of just here following me along, you can also just go in and copy and paste a lot of this in and make sure it's all in the correct format. And you end up kind of just copy and pasting everything over from each of them and combining them together. And that's what I'm doing here, but I'm just typing it out for you. So this, just some basic comments for us so we can kind of see what's going on here. And then have that written there so you kind of see that. So now we have our pin mode set up for 8 and 9. Now we just have to do the LCD setup. In the LCD setup, we did the LCD, the name of what we called it, init, and that was just a open like that. And so that initializes the screen, tells it to wake up. And then we have lcd.backlight, and that's the initialization of the backlight, saying, hey, turn on backlight. This is turn on backlight. If you don't do that, the turn on the backlight, you can try that and just leave this code out. you could just go like this and gray it out and then try uploading this. You won't be able to see the text. It'll be there. You'll barely be able to see it, but having this backlight is very important to see the text. But if you just don't initialize that and don't have that, you can try that by just commenting it out or just deleting it completely. You can just delete it completely and not have that, and then have the rest of the code. And I might show that here towards the end of the video. But right now we're gonna write it as if it's supposed to be written. So we have the initialization of the screen, we have the backlight, and then for this, I want my top line to stay static. I want to kind of tell, hey, we're doing an ultrasonic print here. We're doing what is this? What is this program actually like printing out? What is this reading? And so for that, I just want to do a static print on the top line, LCD. And remember, if we want to use the top line, we have to set the cursor. So it's set cursor 0,0. And so that's just setting the cursor. And now we can print to this. And what I want to do is lcd.print. And anything I put in here it will print it. So ultrasonic. Well, let's do this. Let's do uppercase. So we have, I don't know, I think we have 16 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 characters, yeah. So this will print and fill up the whole entire top line. Exactly. So we're going to leave it there. We're going to jump out. This will print and be static up top. When we start up the screen, it'll just print that. And then our bottom one is not going to be static. That's the one that's going to change with our updating data from our ultrasonic sensor. So we're done here. This is just, remember that this is setting the cursor, and then this is just the title text. It's going to be the title text telling us what's going on. All right, and so then we can make sure we jump out of this and make sure all of our code's inside of our setup for this, because we just got to set up the pins, and then we got to set up the initialization of the backlight. I did this as extra so we have a title so we understand what's being printed. And you can put anything you want here, right? I just decided to say ultrasonic print. And now we're going to jump out of the setup, and we're going to go into the code for printing onto the screen, literally taking in the data from the ultrasonic sensor and printing it on screen. And so essentially we have to do the same thing we did in ultrasonic sensor. I mean, that means turning it off, turning it on for that 10 microsecond ultrasonic burst, and then turn it off again. And then saying, hey, pulse in, take that pulse in and look for that pulse in. And then, so we have to use the trigger pin, and that pulse in uses the echo pin. And then we have to take that and print that out on the screen. Very much like we did with the other code. And so it's just combining those two. So we'll end up, I'm going to get rid of this line here, give myself some space. And then I'm going to start with a digital write, because we have to write that ultrasonic pulse. Digital write. And that's the TRIG pin, and we're going to write it off to initially start with, low. And I think that's, we're going to end up doing that for a microsecond delay, not the millisecond delay. So we're going to do the microsecond delay. Microsecond delay. And I think I did that for 2 on the last one. And then we're going to do a digital write again. I'm going to write it on, so the trig pin on like we did before, high. And then we're going to do that again for that delay microsecond, 10 microseconds for that burst. And then digital write again, trig pin low off. All right, and so that's just the pulse out. That's the turn it off. send this ultrasonic pulse out, and then turn it off again. So now we have that sent out. We got to pick it up. We've got to now pick it up with the echo. And how we did that before was like, I think we did an unassigned long called distance. That's my Alexa. All right, so apparently unassigned long distance before, and then we did the pulseIn, the echo pin high, waiting for that said 30 milliseconds or 30,000 microseconds, right? So we have the unsigned long, which we could establish up front. I'm just going to call this T right now. Could call it whatever you want. I'm going to call it T. And we could establish this up top, up here if we wanted to, right? I'm just going to leave it down here. Unassigned long, pulseIn normal. And then we have the pin, which is the echo pin. And then we have the state, which the state would be high. And then we have the timeout, which is at 30,000. 30,000. All right. And then that's it. That's it for the establishment. Now we have to print. So we have the trigger pin established, and now we have the echo pin waiting for its pickup, right? And so to do that, we're going to print. And so instead of doing serial print like we did on the other one, we're going to do an LCD print. But we want to set the cursor so it doesn't print up top on our title. We want to set it to the bottom. So we have to do lcd.setCursor. There we go. And this is going to be 0, 1, So we're there we go. Shutting that cursor down on the lower would that be line of text? And then we have to do our if statement, because we want that still that same thing that says, hey, you're out of range, or hey, if you're not out of range, print its actual distance in inches. And so it's really similar to that same if statements we used before. It's going to be if, condition, and then statement, and the condition is going to be equals 0. So if t in this case equals 0, because I changed the name from the other, but you can have it as distance. Just make sure you have it set up correctly. Equals 0, and then we have to do this. Yep. All right. So we have our if statement, and then inside that if statement, or we have the condition for the if statement, which is this. And then we have what happens if that condition is true. Well, we lcd.print. And so anything we print right now, because we set the cursor, it's going to say, hey, set cursor to this, and then print this section, or print our else statement. So I'll show that here in a second, or at least the thought process behind that. Out of range. Put a couple of spaces behind that. Right. So if it has a 0, if it's too close, or if it's too far away, if it times out, it's going to be just say, hey, out of range in the lower line. That's all it's going to do. Down here, we want to jump down here and say else, just like we did before. So that's else statement. And the else statement is just this, and it says there's no condition to it. It's just, hey, anything else? Do this, right? I'm going to use that same float. Again, I could establish the float up top, which I probably should do. We'll call it inches equals t divided by the 148.0. And we can close that. So in this case, I'm going to go Control C, float inches equals 0. I'm going to close this, and then I'm going to delete this float here. You can establish it just like I did inside the else statement. You can establish it up top. Sometimes when you're working this stuff through and you're building the code, you don't even know what you're doing until you finally kind of like map it out and then write it down. And so depending on what you're doing, you can establish up here or establish it inside here like we did here, because this could go up here, and I'll just do it for fun like we did before. Unassigned t long. All right, and then I can go down here and back that up, and now t equals that. So same thing. It's just the same thing written slightly different. There's 1,000 ways to write code and set it up differently, but order of operations does matter in most cases. So where was I? Oh, okay. So we just established our conversion rate, so we can get inches. Forces it to be a float, so that it has this. All right. So now we have to print after we've done our conversion, lcd.print, and we're going to do a little indication first and say, hey, we want to say inches, and then print our number, right? Just so we know, hey, inches, like that. I'm going to put a space, and so it'll print this, put a space, close that, and then it'll print. We'll do an LCD print, and we'll do our variable inches right after that. And you kind of see how that works out. So it'll say inches, colon, gap, or semicolon, or whatever that is yet, and then our number on the screen. Print inches, variable itself, right? Comma 1. And that comma 1 is for the decimal point, because we're dealing with a float there, and I only want 1 decimal point. I want 1 decimal point over. So decimal place. All right, and then we can close that by just clearing it out. cd.print. Let's just do this. If we add a decent amount of space there, it will clear out and overwrite any leftover digits from longer values, and it'll kind of clear out the screen. So, all right. And then after that, we're done with our else statement. We kind of want to slow this down. We want to slow down our read rate on our thing. And so we're out of the if and else statements here. We don't want to do this inside. We want to do a delay to finish this out of like 120. You can make it longer. This is just so it's comfortable read rate and update rate. So it updates, or this will roughly update like 9 to 10 updates per second. So it's like, it's updating pretty quick, but it helps us read in that data and actually see it on the screen a little better for that delay, and make sure that's outside of that. So we have our establishment of our trig pin working. We have our pickup of our echo pin. We have our set of our cursor, and then we say, hey, print this. So this sets the cursor. So it's going to say, hey, do this, set the cursor, and then if you don't see anything, right, if it times out or if it's too close, print. So it's saying print, saying set cursor, and then print this. Or set cursor, and then print this, and this, right? And so this is just going to systematically go through and loop and loop and loop and loop and loop. So anything inside those loops, it's just going to say, hey, turn off the pin, turn on the pin, turn off the pin, listen for the echo. All right, set the cursor. Did we see something? Print it out. Oh, we didn't see anything. Print out this. If we did see something, print out this. Delay it, and then go back through again and run that again. So this is just sitting here running again. Just make sure it's all inside that. Just a simple thing, and that's our literal code. That's it. I'll end up adding some text here so you can see what some comments there. But essentially, we can plug on our board, and we can upload it. So we'll go from there. All right, so we have our code here. Just added those comments like I was talking about, where we have section 1 is that trigger, section 2 is the echo, section 3 is our print, right? There goes echo again. My Alexa is called Echo. So, all right, we'll go from here, and I'll just end up uploading this, but I have to select a board here. So I'm going to go ahead and plug in my board, and I have nothing on this LCD or on this Arduino loaded, so it's just going to look like this starting up. Hopefully you can see that. And I'm going to go ahead and select a board, but right now it says Arduino Mega or Mega 2005 560. Now I can try this, and it might work. I don't think it's going to. It's going to come up with an error. It's because it thinks it's a different type of board. It's actually going to sit here and stall out trying to upload to this board using this. And so it's just going to sit here forever trying to upload, and it won't actually work. This might be a problem you have, might be a problem you run into at certain points, but this is an Uno board, and we have to make sure that we're uploading to an Uno. And you can either hit this button, or I think what's actually happening, it might be in tools. Yeah, so our processor is thinking it's that, and which is fine. It's just thinking it's the wrong board, and we have to force it to say Arduino Uno. And to do that, we can hit this refresh button, and it selects Uno, because it actually like analyzes the board and says, "Oh, this is actually an Uno board." But otherwise, you can go over here, and you can go into your boards here, and you'd have to manually select Uno. You can also select any other board here, but for some reason it was selected here, and that's just something that might happen when you first initially plug in your board. You can go in there and manually select Uno, or you can hit that little refresh button, and it will scan the board and figure out that it's an Uno. All right, so we have our code here. We have Uno. We have our board selected. It's correct. Our screen is just on. I'm going to hit upload. It's going to go ahead and compile the sketch and upload. And this time it was successfully uploading done. And now we have a printout. And so if I go in and out with the hand, we can see we're at like 2 inches, 1 inch, 2 inch, and it's printing that out and updating. So if I actually go down here and slow this down, it might slow down just a little bit. Let's go to like, I don't know. Let's go with full second upload. And we're going to see the numbers update a lot slower because it's running that loop a lot slower. So I can put my hand here and then release my hand. It's a lot slower update rate. And that's because of that delay down here that I switched to 1,000 rather than 120. So I'm going to go back to 120. Upload that again. And then I'm going to show you here something. I talked about this backlight. If I don't have that backlight in there and I cancel that out and I can just comment it out like that and it won't run the code, I can upload it, and hopefully we might be able to see this on the screen here. It's not going to initialize that backlight, but it's done uploading. You can barely see in the screen there that it is working, but we have no backlight. Just something I wanted to show you there quick. So re-initialize the backlight there. The backlight will turn on, and there we go. So just something cool there. And then if you actually want to adjust this backlight, there's that little potentiometer on the back, and you can turn it down or up. But there we go.